Question number 6. Figure number 12 shows a device that uses a mug of the hot coffee to turn a wheel. If we look into figure number 12, we can see that the hot coffee is present in the cup. The air above the coffee is getting hot because the heat is transferred from the hot coffee to the air molecules. The air molecules are becoming less denser and they try to rise upward into the air chamber. When they move into the air chamber, they try to go up into this chamber where the piston is present and push the piston. Therefore, the wheel will start moving. If you look here in the question number 6.1, 6.1 is an A1 question. The hot coffee increases the temperature of the air in the chamber. Explain how the pressure in the chamber changes. We know that the air molecules are becoming less denser. They're becoming lightweight. As the result, they will try to rise upward. They have more kinetic energy. As the result, they will collide with each other and the walls of the chamber and the cup more frequently. As the result of that, the pressure on the walls of the cup and of the chamber will increase. Let's see the model answer. Hot coffee increases the temperature of the air in the chamber, which increases the kinetic energy of the air particles. Therefore, the air particles collide frequently and with greater force with the walls of the chamber, which increases the pressure on the walls of the chamber. 6.2 is an A1 question, and this question is from the topic of energy transfer in a system. For the device to work, the air in the chamber must increase in temperature quickly. Explain why the bottom of the air chamber is made of metal rather than plastic. We need to go back to figure number 12 and we have to see why the chamber has a lower surface made up of metal instead of plastic. The air chamber has a lower surface which is made up of metal instead of plastic. The reason is the metals are very good conductor of electricity and heat. When the heat is transferred from the hot coffee to the air molecule, the lower chamber can easily become hot. If it is made up of metal, so therefore it can easily conduct the heat to the air molecules in the chamber. When the air molecules become lightweight or less denser, they will try to rise in this chamber and start moving the piston. So the metals are good conductor of heat and they can easily transfer the heat from one place to another place due to the conduction method. Let's see the model answer. As the lower chamber is made up of metal, so metal is a good conductor of heat, means high thermal conductivity, which allows the heat to be transferred to the air in the chamber more quickly as compared to plastic. And plastics are good insulators. They are not good conductor of heat or electricity. The marks distribution is given on the left side of the answer. 6.3 is an A1 question and this question is from the energy changes in the system and specific heat capacity. The mass of air in the chamber is constant. What property of air allows a small change in the internal energy to cause a large temperature change to the air in the chamber? So we need to find what is the property of the air which is linking the internal energy and the change in temperature. The property of the air which links the internal energy and the change in temperature, that is called the specific heat capacity. But if you look into the question, is there small change in energy and large change in temperature? It means that it transfers the energy from one place to another place very quickly. We will say that the air has low specific heat capacity value. It means that it can transfer the energy very quickly to rise the temperature. Let's see the model answer. The property of the air which links the small change in internal energy and the large change in the temperature, that is low specific heat capacity. It means that a small amount of heat energy can change the temperature of the air significantly. 6.4 is an AO3 question, and this question is from the topic of energy transfers in a system. The changes in pressure of the air chamber cause the wheel to turn. Suggest one way to increase the speed at which the wheel turns. In figure number 12, we know that when the air moves in this chamber, the piston is pushed upward. As a result, the wheel starts moving. We need to make the wheel to move faster. We can make it to move faster by using the lubricant, which helps to minimize the friction between the parts and allows the wheel to move fastly. Or we need to use hot coffee. As a result, the more energy is given to the air molecules, and more air molecules can easily go up into the chamber and move it fastly because the temperature increases the kinetic energy of the air molecules. Let's see the model answer. Using the lubricant to increase the speed of the wheel to turn fast, use the hotter coffee, which increases the temperature and the pressure of the air in the air chamber, and it moves the wheel faster. Decrease the temperature of the surroundings of the wheel chamber because the air particles would move more faster from an area of hotter region to the colder region. 6.5 is an AO2 question. The temperature of the coffee decreases as the device is used. The internal temperature of the coffee was 76 degrees. The internal energy of the coffee decreased by 15 kilojoules. The density of the coffee is given. The volume of the coffee is also given in our question. The specific heat capacity of the coffee is also given, that is 4200 joules per kilogram degree Celsius. Calculate the final temperature of the coffee. We know that with the time, the temperature of the coffee will decrease. As a result, the kinetic energy or the internal energy of the air molecules will decrease. Therefore, the speed of the wheel is also reducing. We need to find the final temperature of the coffee. If we go back in our question, we can see that the initial temperature is given, that is 76 degrees Celsius. Specific heat capacity is also given. The density of the coffee is given, that is 1.1 10 raised power 3 kilogram per meter cube. The volume of coffee is given. We have the value of energy, that is 15 kilojoules, and we need to convert kilojoules into joules. It means we have energy that is 15,000 joules. We need to find the final temperature of the coffee. If we want to use the formula of specific heat capacity, the mass in the equation is missing. First of all, we need to find the mass of the coffee, and we need to use the formula of the density, and we need to use the volume in the formula to find the mass of the coffee. Let's see the model answer. We know that the density is equal to mass per unit volume. The density is given, the volume is given. We will substitute both of these values in our formula. The density is equal to 1.1 10 raised power 3 is equal to mass over volume, that is 1.9 10 raised power minus 4. It will go on the other side and will times. We will use the calculator, and the mass of the coffee is 0.209 kilograms. Now we will use the formula for specific heat capacity, and the formula is energy is equal to mass into specific heat capacity times the change in temperature. We will substitute all the values, the energy, mass, specific heat capacity. These two values will go on the other side and they will divide, and we will find the change in temperature. The change in temperature is 17.088, which is actually the drop in temperature. We know that the initial temperature of the coffee is 76 degree, and it will drop by 17.088 degree. So the final temperature is 58.912 degree, which is approximately equal to 59 degree. So this delta theta is showing actually the drop in temperature, and we need to use the initial temperature, which is 76 degree. So we will get at the end 59 degree approximately.